Hey everyone, welcome. Today we're jumping into one of the trickiest puzzles in AI. How do you teach a machine to have, good judgment? It's not just about getting the right answer. It's about understanding why it's the right answer. We're going to be breaking down a really cool paper from Tanguy Lab that has a pretty clever solution.
Think about it. This is a huge question. We want our AIs to be more than just calculators or encyclopedias. We want them to be genuinely helpful, empathetic, maybe even wise. But how on earth do you write code for something as human as judgment?
Let's make this super simple. Imagine you're learning a new skill. If your coach just says, "Yep, that's better," it doesn't really help you improve, does it? But if they say, "That's better because you did this," which shows more empathy, suddenly a light bulb goes on. You're not just learning what to do, you're learning why. You're developing judgment. And that difference right there, that's the key to this whole thing.
So, how are we grading our AIs right now? Let's take a look at their current report card.
Well, the standard way we do it is actually pretty basic. We show an AI judge two different answers to a prompt, and we just train it to pick the better one. It's a simple A or B choice, a thumbs up or a thumbs down. This is what's called pairwise preference, and it's all about the final outcome.
Now, to try and get a little more sophisticated, researchers came up with something called a generative reward model, or GRM. The big idea here is that the AI doesn't just pick a winner, it also has to write out its homework, basically. It has to explain its reasoning in a little critique. Sounds like a huge step up, right? Well, there's a catch. And that brings us right to the heart of the problem they discovered. What happens when the AI picks the right answer, but for a totally wrong or even nonsensical reason? The paper uses this absolutely perfect example. The AI gets a prompt that's all about human emotion and sensitivity.
And it comes up with two different answers. Response A is pretty much what you'd hope for from a good friend. It's supportive, it validates their feelings, offers real help. Response B, well, it's a bit of a disaster. It's full of empty cliches, that kind of toxic positivity. I think we can all agree. A is the clear winner here.
But get this, the AI judge, it actually picked response B, the bad one, and its reasoning is just so shallow. It latched onto upbeat energy and completely whiffed on the total lack of genuine empathy.
Now, here's the critique from a human expert. It's insightful, it's specific, and it absolutely nails the problem with response B. The difference in judgment here is just night and day.
And the researchers gave this phenomenon a name: outcome process inconsistency. It's when the model just happens to stumble into the right answer, but its reasoning, its process, is completely broken. Rewarding that is like telling a kid they're a math genius because they guessed C on a multiple-choice question. You're not actually teaching them math, you're just teaching them to be lucky. And this chart really shows you just how big of a deal this is. For something objective, like math problems, this inconsistency is pretty rare, only about 6% of the time. But look at the subjective stuff, the rewarding tasks, like our comforting message example. It skyrockets to 20 or even 30%. That means for almost a third of these nuanced tasks, even the best models are basically just guessing right without really knowing why. Okay, so we've got a serious problem. How do we fix it? Well, the paper's solution is really elegant. You make the AI learn not just from a grade, but from an expert critic. They call their method RM-NLHF. It's a mouthful, I know. It stands for Reward Modeling from Natural Language Human Feedback. But the key idea is simple. This whole system is built to reward the AI for its reasoning, not just its final choice. Here's how the magic works. First, the AI still gets points for picking the right answer. That's the outcome reward. But, and this is the game changer, only if it gets the outcome right, it moves on to step 2. Its own little critique gets compared to a gold standard one written by a human. And if the reasoning lines up, boom, it gets a bonus process reward. This makes sure we're only rewarding good thinking that actually leads to the right answer. Now, this is a fantastic idea. It's brilliant. But like a lot of brilliant ideas in AI, it immediately slams into a giant real-world wall: scale. Let's be real. You just can't hire an army of human experts to sit there and write thousands, millions, maybe even billions of detailed, high-quality critiques. It would take forever and would cost a fortune. It just doesn't scale. So what do? If you can't get enough human teachers, you do the next best thing. You teach an AI how to be a really, really good teacher. And this is the masterstroke of the paper. They created what they call a meta-reward model, or MetaRM. The best way to think about it is as an AI student teacher. You give it a small, curated set of examples with those amazing human critiques.
It studies them, it learns what good feedback really looks like. And then, once it's graduated, you can let it loose to provide that same quality of feedback to other AIs on a massive scale.
And they even took it a step further. An offline MetaRM is like a teacher that's trained once on a set curriculum. It's good, but it's static. The online version is even cooler. It's like a teacher that keeps learning and growing with its students. As the main AI model improves, the online MetaRM gets updated with new human feedback, so its own teaching style stays sharp and relevant. So, we've got this super clever, scalable solution. But, did it actually work? Let's look at the results and see if they really managed to create a smarter AI judge.
And here it is. This is the visual proof, and it's pretty stunning. On the left, you see a word cloud showing the most common words in the critiques from the old baseline model. On the right, that's the new model trained with their method. Just look at the difference.
Let's break that down for a second. The old AI uses these generic, fluffy, positive words. Provides, comprehensive, helpful. It's vague, kind of like corporate praise. But the new AI, it's learned the vocabulary of a real critic. It's using sharp, precise, and often negative words. Unusable, incorrect, critical, unrelated. It's not just handing out gold stars anymore. It's actually diagnosing flaws. It has learned true judgment.
And that just leaves us with this really fascinating thought to chew on. Sure, this research is about making better AI judges, but the implications go way beyond that. This is a step towards an AI that doesn't just give us the answer we asked for, but an AI that can understand why we're asking and maybe even challenge us when our own reasoning is flawed. So what happens when our AI collaborators can help us sharpen not just our answers, but our own thinking? What does that future look like?